Hello, this is a video lesson about two-way tables. This is part of our Statistics Unit 3. Unit 3 in our class is all about looking at situations where we have two variables. So far we've looked a lot at scatter plots because scatter plots are a graph that can represent two variables that are quantitative. However, sometimes variables aren't quantitative. Sometimes they're categorical. And in those situations, we would need to use something else because we aren't going to be able to make a scatter plot of categories. And one way of handling categorical data then is to make what is called a two-way table. So the other day in our class, I asked you to tell me if you had a dog or a cat or both or neither one. And so this is an example of what I mean by a two-way table. It's called two ways because one of the ways or one of the directions shows one of the variables. In this case, the variable is do you have a dog or not. Those are categories, not counts per se. And then here, the other variable or the second variable is whether or not you have a cat. So it's called a two-way table because it's displaying the relationship between two variables. And these particular two variables yield four different categories: having both, having neither, or having just a dog or just a cat in this case. Okay, so those are the four different outcomes. Now, in our survey in class, we got this result. With my classes added together, we found out that there were 7 people in this group, 3 people in this group, 18 people in this group, and 4 people in this group. Okay, so those are our results. If you read the headings on the table, you can understand what each of those 4 groups is. Okay, now based on this table, we should be able to answer these questions. How many people do not have a dog or a cat? Do not have a dog or a cat. So which cell is that? You're right, it has 4 people. 4 people do not have a dog or a cat, and that's read right off the table right here. Okay? How many people have one or more dogs? So basically, the one or more just means like if you said you have a dog, it didn't matter if you had a dog or 2 dogs or 3 dogs, that was just the group have a dog at home. So how many people are dog owners, have a dog at home? Well, you might be tempted to say 7, and you might be tempted to say 18. But notice that this question just asks about dogs. It doesn't ask about the cats in your family. It has nothing to do with that. So you actually need to total up this column because this is the column that's about dogs. So that total is 25, and that is what we will call a column total. We've added up the column. How many people have one or more cats? This is similar to question 2, except now it's about cats. And because it's about cats, it's not actually a column total. It's the total for this row here, which is 10. And I know you're going to be amazed to hear this, but that's called a row total because we added across the row. And then it says how many people have at least one pet? Well, the pets we're talking about are just dogs and cats. So this does not take into account if you own a rabbit or a horse or anything like that. But just by looking at dogs and cats and who does not own a dog or a cat, well, we might want to do some more subtotaling. So the people who don't have dogs, that totals up to 7. That's that column total. The people who do not have a cat would be 22. So this would suggest that we had 32 students present the day that I did this survey in class. And of those 32 people, we already looked at these 4. What were those 4 folks again? Right, the people who don't have a dog or a cat. So if there are 32 people total and 4 of them don't own a dog or a cat, that means that 28 people do own a dog or a cat. Okay? So that would be one way to handle it. We also could have added together these 3 numbers. Okay? That's the same exact consequence. Now, that hopefully shows you kind of your way around a two-way table. The importance of the two-way table in probability or statistics class is actually to determine probabilities, okay, and be able to look at that. So in your notes page, you'll see that I have defined 3 different kinds of probabilities. These are vocab words that you should make yourself very well acquainted with, because I can see myself asking you some questions like that on an assessment, just naming them. But the point in naming them is not just to be able to know the vocabulary, but I think if you can identify the kind of problem you're doing, it makes it a little easier to actually do the correct calculation. So, for example, the first term here is what is called a joint probability. And a joint probability question is always going to use the word and. And that kind of probability, a joint probability, is found by taking a cell count. Now, a cell in a two-way table is just one of the boxes. So take one of the cells or one of the boxes, and you divide by the grand total. So an example of this would be, let's say I wanted to know the probability of someone in our group of students owning a dog and a cat. Now, in reading that, I can see that it's a joint probability question because it uses this word and. And as soon as I see the word and, I say, oh, that means I want to take a box from my chart, a cell, and divide by the grand total. Look back at our chart and say, well, I'm trying to find the probability of dog and cat. So which number is that? Well, has a dog, has a cat, is this number right here. So I must be taking this 7, and it's 7 out of what? Out of the grand total. Which number up here is the grand total? This one. So I know that to find the probability that someone in our trig stats class, if I want to know the probability that a given student has both a dog and a cat, that probability is 7 out of 32. That was a cell count that was in one of the boxes. This was a grand total, okay, the total number of students. So you see the payoff of knowing that joint probability is the one with an and then associating the fact of joint probabilities are cell over grand total, it makes it really clear how I find that particular answer, how I find that particular probability, okay? Let's go to conditional probability. We have actually seen conditional probability before in our very first stats unit. Conditional probabilities always use the word given or the word if, okay? So, and the way that you find a conditional probability in a two-way table is to take a cell count. So again, that's something that's in one of the boxes. But this time, instead of dividing by a grand total, you're going to divide by a row or a column total, depending on what the question is. So, for example, it says here, we might want to find the probability of having a cat given that you already own a dog. Okay, what those words mean are we're going to take, instead of all the students taking trig stats, we're going to take just the people who own dogs. And then out of that group, figure out how many also own cats. So if you look at our table, what is the group that owns dogs? How many folks own a dog? Well, that would be this group right here. Now, out of those 25, look back at the question. Out of those 25, we want to know how many of them own a cat. Just out of those 25, though. So out of these 25 people, how many of them own a cat? 7. So our conditional probability here is 7 out of 25. Out of the 25 dog owners. Sorry, my board is really misaligned. I'm trying to write a 25 here. Oi, give me a second. I'm going to pause the video. Okay, sorry about that. It was really weird. Okay, so out of the 25 folks who own dogs, 7 of them own cats. And so the probability that a random student would own a cat if we already knew that they were dog owners would be 7 out of 25. Okay, the last one, marginal probabilities. Marginal probabilities only use numbers that are found at the margins of the table, okay? It's a really, really good name. So the margins are these numbers here that are at the edges of your table. Marginal probability only uses numbers at the margins. And you're going to recognize marginal probability if it's a question that only mentions one variable. So if I have a question that's like probability of owning a cat, and it doesn't mention dogs. Probability of owning a dog, and it doesn't mention cats. Or probability of not owning a dog, not mentioning cats, right? Any of those would be a marginal probability. So let's try doing a couple of those just to make sure you understand what I'm saying. Okay, so the probability of owning a cat in our group, well, how many cat owners were there? Hopefully you're reading right across this line and you see, there were 10 cat owners. Okay, out of how many people? 32. So our probability of owning a cat in our group was 10 out of 32. Okay, that is a marginal probability. The 10 and the 32 were both numbers from the margins. This is a question that doesn't mention the other variable. There's nothing said about dogs. So it's a marginal probability. Another one would be this. The probability of not owning a dog. Okay, we look back at our table. Does not have a dog. Total was 7. So our probability for not owning a dog, no mention of cats, don't care about the cats, 7 out of 32. Okay, so I hope that these 3 examples drive home the 3 kinds of probabilities. The next part of your notes, I just wrote in a chart, and the 2 variables here, I hope you can tell what they are. What are they? What's the one that's across the top? Gender, right? So there's one variable, gender, and then this variable is actually labeled. It says grades. Okay, so we have variables of grades and gender, and then in each cell, rather than writing a number, I just wrote like row 1, column 1, row 4, column 1, row 3, column 2. That's what those symbols mean. And then, so the cells are actually just these 4 groups here, right? You can have A's, B's, C's, and D's in my chart. You could be male or female. Those are 8 different outcomes. So the red highlighted parts, those are the cell counts. And then at the bottom, these are column totals, as I've labeled. Over here on the side, these are row totals. Okay? So that's the setup of the table as a whole. And underneath, I've asked you to tell me what these different fractions tell us. So if I were to take R2C2, that's row 2, column 2, if I were to take this number and divide it by the grand total, my question is, what is it that you would be calculating? It's some probability. Well, let's think about what that cell represents. That cell are people who are female, and they get B's. And I'm taking it divided by the grand total. So this must be the probability of being female and a B student. That word "and" tells me that the kind of probability we're looking at here is a joint probability. See the word "and" in our notes before? And we took a cell and divided by the grand total. Okay, so this is an example of a joint probability. Okay, and the joint probability we were looking at was female and B. Okay, now the next one asked us what is going on if we take C2, column 2, that's this one, and divide it by the grand total. What does column 2 measure? Column 2 is how many females there are. And there's no mention about grades. So this is female, no mention of grades, so it must just be probability of female. What kind of probability is it when you ignore one of the variables? It's marginal, right? We just use numbers from the margin. So we're going to say that this is a marginal probability. Okay, what about this next one? R2C2, so this again, divided by this time R2. Okay, well, when I'm not dividing by a grand total, that's a big tell. That tells me that I must be doing a conditional probability, right? Conditional probability is the only time you're going to be dividing by a row or a column. So in this case, the assumption I'm making is that we are in row 2, which is the B category. Okay, so this is the probability of something, assuming that I'm in the category of B students. And if I look at that cell is the cell of females. So this is the probability of female, assuming that you're only looking at the group of B students, okay? And this is example of conditional probability. And the last one must be a repeat, because now we've hit all 3 kinds. So R2 divided by the grand total. R2 is row 2, which again represents B students, as we were just saying in the previous question. So this must be the probability of being a B student. It doesn't mention anything at all about gender, okay? And so again, because we're ignoring one of the variables and only using things from the edges of the chart, that's a marginal probability. All right, so now we're going to do a couple practice problems. In this practice problem, it says that there are 40 children who are members of a cycling club, and then the two-way table tells about their bikes. The bikes, the two variables mentioned are the type of bike and the speed of the bike. It is very important that you notice it said that there are 40 children, and so that tells me, if I were to extend this for margins, my grand total is going to be 40, okay? So I'd like you to pause the video, figure out what that missing cell is, figure out those marginal totals, and then we'll figure out the questions together, okay? Take a minute and figure it out. Okay, I'm up to here in my work, and I know the grand total is 40. If I do a little figuring out here, I know that these four numbers have to add up to 40, just like these numbers over here added up to 40. So I can make a few deductions. For example, I know that this row has to be 14 in order to make those numbers add up to 40. And if that's 14, this row has to be 14 in total, which means that the missing number there is a 6. Okay, so that was what they asked us to do for 1. For 2, it says, how many children have mountain bikes? Well, that's 11. And for number 3, given that a child has a racing bike, notice this word given, okay? So this is a conditional probability type situation. Given or assuming that a child has a racing bike. Okay, so we're looking within this column. Given that a child has a racing bike, what is the probability that it's also a 12-speed? Well, the 12-speed racing bikes, there's 6 of them. Out of how many? 8. Okay, so 6 out of 8 are 75%, and it was a conditional probability. We're only looking within the group of racing bikes. Okay, the next one says, what is the probability that a randomly selected child in this group has a BMX bike? The BMX bikes are right here. Notice that the question didn't ask anything about speed, so this is just a marginal probability question. We are going to take that 15 and put it out of the grand total. The next one, what is the probability that a randomly selected child in this group has a 12-speed bike? Notice that it mentions speed here, but it doesn't mention type. So again, this is a marginal probability question. We'll look at the 12-speed bikes. The total number of 12-speed bikes is 14. We don't care about anything other than the speed in this question. What was it again? 14. So we'd say 14 out of 40. And number 6, what is the probability that a randomly selected child in this group has a bike that is a 15-speed and a mountain bike? The word and should tell us it's a joint probability question. And if you look back, you'll remember that cell divided by grand total is how we do a joint probability question. So 15-speed and mountain bike. 15-speed mountain bike. That's this one. So we have 2 then out of 40 as our answer. Now, with any of these fractions, you're welcome to reduce them or to put them in decimal form. It doesn't matter to me as long as you have the correct numerical value. Now, there are 2 more questions. Tomorrow at the start of class, I am going to verify that you have these done and done correctly. For each one, you need to make your own two-way table. I'll get you started, okay? So number 7 says, in a car showroom, there are 8 blue cars, 1 is a hatchback. 6 of the 20 cars in the showroom are hatchbacks. How many cars are not hatchbacks and are not blue? So maybe a tricky thing here is to figure out which variables you have. So you have to kind of read carefully and decide what's mentioned here. And I think one of the things that's mentioned is blue versus not blue. So that seems to be a grouping. And then the other thing that's mentioned is having a hatchback car. That was kind of a common kind of car in my day, hatchback cars, okay? And then things that are not hatchback. Okay, so that might be our starting point. It does mention that there are 8 blue cars total. 8 blue cars total. So I think what I'd like to do, I need to draw another line over here. 8 blue cars total, and it says one of them is a hatchback, and 6 of the 20 cars in the showroom, so I think this is 20 down here, 6 of the 20 cars are hatchbacks. And I think that's actually enough for you to get there. Okay, so there's a start on number 7. You'll have to fill in the rest of the table and then answer this question. Okay, for number 8, let's try this guy. Get a little start here. Okay, in this problem, let's figure out what the variables are. It says there are 32 students, so I think that's going to be our grand total. And there are girls, and they play hockey, and there's boys. Okay, I think I see what the variables are. So I think there are boys and girls. And there is hockey and not playing hockey. Okay, I think that's the setup. There are 8 girls who played hockey. That would be here. And 5 boys who did not play hockey. We want to know how many boys played hockey if there were a total of 15 girls in the class. Okay, so 15 is our total for girls. You guys need to figure out the rest of the table and then answer this question. So at the start of class tomorrow, be sure to have this out, and I will be giving you some credit for finishing these out and doing your best. Thank you for listening to the video and taking notes. I'll see you in class.